So welcome. My name is Xenofon Dimitris. I'm a professor of American Informatics and Data Science here at Yale. This is another of the supplementary videos we're recording for our new program in medical software and medical AI. My guest today is Oleg Yusim, who's now Senior Director of Information Security at Edwards Life Sciences. He has extensive experience in cybersecurity, both in the medical world and in other tech areas. So Oleg, welcome. Just please tell us a little bit about yourself and how you got here.
Thank you, Xenius. Thank you for inviting me. My work right now is in product security of medical devices, and it mostly focused around helping to ensure that medical devices my organization is releasing to customers are secure, and they will, most importantly, stay secure as customer will start using it, and they will be potentially subjected to some unknown yet vulnerabilities. So short and sweet, that's what I do.
Okay, well, let's slowly roll the ball. First, a simple question here. Cybersecurity is well known as a field. I don't think we need to worry about it too much, but what's special about medical devices? What's different in this area? Are there some unique aspects of cybersecurity that are unique to the medical device universe?
Yeah, sure. So I would say the life critical aspect of medical device as a product, putting very interesting spin on cybersecurity approach. Typically, if you will look around the news, you will take a look at general high-level courses. You will try to build your understanding what cybersecurity is really, what cybersecurity really cares about. You will conclude cybersecurity cares a lot about confidentiality of the data. You will be confident by the end of your 1 hour research about this. Even the mere definition of cybersecurity breach typically means attacker was able to penetrate the protection of the company, get in, and steal the data. So confidentiality of the data seems to be a paramount. Now, in medical devices, it is absolutely not the case. In medical devices, what is much more important is availability of that medical device at all the time. And equally important, integrity of the data on that medical device, integrity of the environment of the medical. Because if one of those two is not here, then the patient's life can be in danger. Absence of medical device, available medical device, might endanger patient life. Medical device which produce incorrect data or work base of incorrect data might endanger patient life. Now, is the confidentiality still a concern? Well, yes, of course it is still a concern. But if you will ask me to range my concerns, it would be my third concern, not the first concern. So that's really, I would say, the major difference between world of medical devices, product security, and outside other world of cybersecurity.
So when we think about cybersecurity in the context of a medical device, when does the process start? Like, when should somebody begin to worry about cybersecurity? How early in the development process would you want somebody to call you? When is it too late?
Well, obviously, the earlier the better. So, actually, very good question. So let's talk through that. Let's imagine a timeline, and let's pretend for a second that I'm an R&D engineer, and I just got a brilliant idea, and I want to start working. So once I'm doing some real mocking around. I'm just trying to put together something and see if it even gonna work. I don't need product security in my device. I might need I might need cyber security, information security to secure my environment where I'm working. But in my device, I don't need at this point product security. However, let's say I'm getting a little bit more serious and I'm saying, okay, now let me put together a prototype. I'm gonna show my leadership and gonna put together an argument that that prototype is worthy of investment money into it and worthy of becoming commercialized product potentially. So here I will already start buying hardware, which I actually mean to keep in this device once it's graduating from prototype to actual commercialized product. Here I already starting to define major software components, which again would survive such change. For instance, operating system, or what kind of middleware are gonna be running, this type of things. Now, once I started to do that, that's absolutely a moment to call it, because even such simple, really looks pretty not security related, thing as selecting processor, CPU, is actually having great cybersecurity content and context. And in this particular case, processors today are not created equal. Some of them are able to perform cybersecurity functions or system on module, which is more advanced chipset than processor. Some of them include cybersecurity chip, and some of them don't. I'm talking about TPM or something of that sort. So it's very easy to make that decision, make a purchase, and realize that, well, cybersecurity was left outside. Now, it is much more difficult now to walk back in time and tell Intel, oh, wait, stop the shipment. I didn't mean it. I actually want that chip, not this chip. So to avoid all this situation and make sure it's not happening, it is very important to engage product security engineer at the moment you're starting to make decisions on hardware or software, which will actually survive the transition from prototype to commercialized.
Yeah, it's the same story when I talk to my friends who are in statistics. They say, you have to talk to us at the start. It's too late once you start doing things. Again, similar story.
Absolutely, Xenius. And I totally understand why people sometimes don't do that, because unless you know, you're looking at processor. What is the security concern with the processor? It's a processor, for crying out loud, right? Or you're looking at Wi-Fi chip. All Wi-Fi chips created equal from cybersecurity perspective, or at least it so appears, right? But really, it's not the case. So definitely, the moment you engage, at the moment you starting to make decisions on hardware or software, which would survive your prototype and move into commercial, engage product security engineer before you made this call and hear this person out.
So if we look at the medical software lifecycle for software and software plus hardware, risk management is a continuous process, right? We worry about it throughout, from the beginning to end, from before birth to after death. We're doing risk management essentially in this process. What is the interaction of the cybersecurity process with risk management? Because I assume that that's really where it fits in the sense of the life cycle, yes?
Well, risk management is super important part of what product security and cybersecurity overall is doing. Because think about it this way. Um, how much cybersecurity is enough cybersecurity? It's a key question, and as funny as it might sound, it's super important question. I'm very passionate about cybersecurity. I would like to secure your product the best way I can. But now let's assume you, Ksenia, is the CEO of this company. Do you want me to secure your product the best way I can? Do you need me to secure your product the best way I can? Where is that magical boundary where I already secured it enough for your purposes? And now I'm doing everything else, which is a fine art of security, which I really enjoy. But for you, from business perspective, it is already the spending which outweighs the risk, and you don't want me to do that. How do you find that boundary? That's where the risk management comes. The risk management is essentially the art of evaluating the risk related to some kind of a weakness in a product, cybersecurity weakness in a product. And depending on the risk appetite of the organization, classify that risk as high risk, a medium risk, or low risk, and decide what we're going to do with high risk once we determine that, what we're going to do with medium risk once we identify it as medium, and what we're going to do with a low risk. And that will go across the whole life cycle of the product, just like you said, it would be equally applied when we will decide, should we implement that security feature or not, when we only preparing our product to go into the market. And when we will decide, oh, is that vulnerability worthy of the patch? And if it is, how quickly should we roll out the patch after we already deployed that product on the market? And so risk management is definitely super important part of product security. Some would argue the most.
I mean, in many ways, if I look at put my software engineers hat and I think of medical software, the big difference between medical software and it's in non-medical software is precisely that centrality of the risk management process throughout this. Now, so I heard you say it was like, low risk, medium risk, high risk for cybersecurity. How do you even begin to tell those things in a landscape that changes, right? We discover threats all the time. This is not just, unlike other safety issues in medical devices, which hopefully we design it properly and that's the end of it. Security, other people are trying to create problems for us. Yes. So how do you classify those things? What are some of the tools available? What's your monitoring? How does it change over time?
Sure. Wow, that question, it's a master level course, Ksenia, and we would be just scratching the surface. I will try to fit it into 5 minutes. So the typical approach to evaluation of cybersecurity risk in medical devices, it's essentially a product of what's called exploitability, which is essentially how easy for attacker it would be to exploit that risk times impact, whatever that impact might be. For instance, for patient safety, that impact would be the severity of harm that risk, if materialized, would cause the patient. But let's say for privacy risks, or should I say, the possibility of losing sensitive data, that might be how many records we're gonna lose, and how sensitive those records are going to be. So depending on a risk profile, that impact can be expressed through different terms. Now, the next good question might be, okay, well, exploitability is awesome. How do we calculate exploitability? So the common approach today, which is not perfect, by the way, not perfect, but the common approach today is to calculate exploitability using CVSS calculator, which you all can find online if you would just Google it. It's a short for Common Vulnerability Scoring System. I'm sorry, so yeah, Common Vulnerability Scoring System.
We can add the link to the notes, so that's fine. So,
this is very common calculator for all information security. When you will look at any published vulnerability coded as SV number, you will notice that there is a score associated with that vulnerability ranging from 0.1 to 10. And depending on how high the score is, that risk is called either critical, or high, or medium, or low. Well, these numbers from 0.1 to 10, they're coming from CVSS calculator. So it is commonly agreed medium today to calculate that score. Now, once again, is that a perfect way? I would argue that. In Edwards Life Sciences, my team has developed an alternative solution to make calculation of risk, cybersecurity risk, for medical devices more precise, and we called it HVSS, Healthcare Vulnerability Scoring System. From our standpoint, it is far more accurate representation and far more accurate mechanism, but we only introduced that to the industry right now, and we rolled it out as an open source project. So we will see if that opinion would win over the more traditional one. Yeah, that's, I would say, if we summarize that, again, exploitability times impact is most common approach to calculation of those risks.
Okay. So one of the things that, and this is a theme I've had some other discussions about, use of AI in medical software. And it's a common thing between that and cybersecurity that you're never done, right? You have to keep monitoring. Okay, you managed to get to the FDA. I have some questions about the new FDA guidance. We'll say that for a bit later. You managed to get through, your product is on the market. In some ways, that's where your problems start, right? You have to keep an eye on it. And that's where you're sort of in a reaction mode. You have to monitor and react. What does that process look like from the inside? So you guys have products on the market. What is sort of your monitoring like? What is your reaction situation like for these products right now?
Right. So this is the difficult one, Xenius. You see, and to be fair, let's not talk in this situation about medical devices as if it's one big category. It is, let's break it down. There are medical devices which would say it's a cloud solutions, which are deployed in cloud Edwards Life Sciences control. We have then all the tools, really all the cybersecurity monitoring tools, runtime tools, based on the logs tools, threat analysis tools, all of that, to monitor that environment. We can monitor it as well as we monitor an enterprise cloud, or even better. And all the traditional means of response are also available to us. All the, incident detection, our response team, which is here to jump on it, all of it is here. So That's the best case. Now, then we have mobile application. This is a little more challenging, depending on if this application sending the logs home or if it's not, and the time to response becoming more because this is already a situation where we might not be able to just turn this application off. We might need engagement from the user side to install the security update, even if we were able to provide it very, very quickly. And then final step, and this is where the delay between detection and response might be the greatest, is the situation when our devices are deployed on hospital premises and they're fully disconnected from us, from Edwards website network. They don't report home. At best, they report to uh, hospital uh, information system um, and hospital information security might feed from these logs if they will choose to. That's the situation where the the gap between our detection of the risk and the remediation being actually applied to device is absolutely the greatest. Because first we will have to, without detection, work of the representation of this device we have at home. We will have our scans of the code, we will have our scans of third-party libraries. We will be able to detect and identify new vulnerabilities coming out on that software bill of material. However, and we obviously would be able to initiate the patching process if we, upon our risk analysis, see that they actually gonna impact device and cause a high risk. But here's the gap. Let's say we did our job, we made the patch available. Now we have to either send technicians to all the hospitals in the world where these devices are deployed so they can install this patch, which, as you can see, would be pretty expensive and also pretty lengthy proposition. Or we can make that patch available over network, let's say some kind of portal, for our customers already to download them on some carriers and install it on our devices themselves. But in this particular case, this is where we're passing the baton to hospital and we're saying, look guys, you have a risk. Here is the patch. Please install it. Now, would hospital install it or not, considering that they're typically very short-staffed on security side of the house and super busy, maybe with higher risks than that, it's a question. How quickly they're gonna get to that? That's another question. So all in all, post-market support right now is absolutely we super focused on it. We're trying to put our best effort in, but is it ideal? Absolutely not.
How common is it for devices like this to phone home that you can push updates? Do hospitals let you even do that, or is that touchy?
It's not recommended. It's really not recommended. So the typical schema, if you would like to put it this way, which I can see, would be to introduce a server on hospital premises. So let's say Edwards Life Science introduces server on hospital premises. That server can listen to Edwards Life Science, let's say, cloud instance or something like that, and consume updates from there. But downloading updates on actual medical devices connected to actual patient is better from that server and upon request from medical device, not otherwise, or it can negatively impact the primary function of the device.
I have a couple of points. When we talked before, I have some bullet points here that I want to bring up. The first is this whole concept of threat modeling. And maybe you covered this before, but if there's more you wanted to say about threat modeling in general.
So, Xenius, the threat modeling, you can see it as essentially a mechanism to identify weaknesses in medical device software from cybersecurity perspective. So how does it look in lame terms? It means that we look at device architecture. Sometimes in simplistic manner, we can just draw it in a whiteboard. Mm-hmm. And then we start thinking, okay, what can go wrong here? Okay, that communication between our device and EMR. Can attacker potentially intercept it? And when I say EMR, I mean, you can think about it as a main hospital database. Can potentially attacker intercept it? Can attacker steal that valuable data? Can attacker change this valuable data? Can attacker jam that communication and not let it happen? Can or cannot? Okay, can. Then what's gonna happen with the device? What will happen with the main function of the device? What will happen to the patient? Then let's look at something else. Oh, we have an ability to export treatment reports from our device over the USB. Can unauthorized personnel get access to that? Can or cannot? So you really can go over many aspects in this manner, and putting on the attacker hat, putting on the type of thinking, how can I misuse it? You can find and discover and enumerate a fair amount of attack scenarios, which are most likely to happen because those are the ones which came to your mind first. And then you have two routes to go. First, you need to make sure that you have cybersecurity requirements which are closing these attack routes, and team is implementing. Depending on how easy this threat would be to exploit, and that's where we go in again into risk management, because those threats would serve as an input into risk management mechanism where the risk associated with this threat exploitation can be evaluated. And depending on how high that risk is, you can prioritize your requirements for development team. Because frankly, the situations where cybersecurity engineer gives team 30 requirements to implement, and team comes back and reports all 30 were successfully implemented, happens about never. Usually teams are short on time, short on staff, short on something else, and they can implement 10 out of the 30 requirements, or in a good day on a good project, 15. So which ones? That's my job as a product security engineer, to identify and tell which ones. And that's where evaluation of the threats from risk perspective helps me. Because let's say I have a threat associated with sending data somewhere on a protected network. And let's say I have another threat which is associated with somebody opening the box, soldering some wires into the board, and then in a very tricky manner, finding out my 22-character passwords, starting to intervene with the work of the processor. So which one I want to take care of first? Well, obviously the communication one. But why? Because when I was calculating exploitability, part of the risk, it came out much higher for the risk associated with exploitation over the wire versus the one where I need to solder something to the board. So that's really in nutshell what threat modeling is, how it works, and why it's important to have. But it's not even 10,000 feet. It's 100,000 feet description.
When you look at threats and you look at issues that arise, some of those issues are, let's say, code problems or hardware problems, and some of them are human problems, right? People not doing proper good things. I mean, at least in the university, what about passwords? What about those things as well? What's the split in your experience? How much are the problems caused by the user as opposed to the device? I mean, obviously, the two are tied in some ways.
It's super tight. I honestly wouldn't even split it this way. At least I don't think about it this way. Any user, I would put it this way. User will make any error which you allow user to make. I would take it even a notch further. The device would be misused in any possible manner which you explicitly didn't prevent it from. So if you left an ability for user not to change the password from default password all devices are shipped with, be rest assured they will not change it. If you left ability for user to not change their password ever or have a simple password which is 4-digit long, absolutely they will send it to 333 and it will stay like this forever and whole hospital will have the same password. So all these assumptions you can safely make, and the nature of us as human beings is such that they would mostly come true. So assume the worst and be very inventive and try to enumerate the infinity in this case, and put controls which would not allow that scenarios to happen.
Oleg, we've talked for a while. I don't want to keep you much longer, but was there anything else that you wanted to bring up? Did we skip anything that you felt was important to mention on any of these topics that we failed?
I mean, first of all, Ksenia, thank you very much for inviting me. I really appreciate it. It was a great conversation. Really enjoyed it. I would say one thing, considering your students would be listening to that, I would mention. Right now, it is very exciting, and in my personal opinion, maybe unbiased area, has a great shortage of stuff. There's not even close. We have probably few orders of magnitude different between the amount of specialists we need and the amount of specialists we have. And if any of your students would have a genuine interest in learning this area, I would strongly encourage them to do that because it's definitely a very big gap on the market today. I'm pretty okay with them reaching out to me if they would like more detailed guidance on what to start from too.
Oleg, thank you for taking the time.
Thank you so much, Ksenia.